Well, I guess I need to make another video ready for YouTube because it's been a while. Oh, I got feedback. Hang on. Ugh. Right. Anyway, since I started working on this thing, um, one of the most important aspects of it I've noticed is angles and the angular approach paths for the iron and for the magnetic flux to flow down. And so the old design, the previous design, I should say, let me just find it. Right, okay. It's pretty much straight through. If I can find the flipping image. Okay, right, that one. Right, the current design is just using straight. I better bring it in my paint program so it's centered, whatever. But the problem with that is because the laminations are in a straight line, and the flux, there's not an easy control for the flux and where it goes. Obviously I'm in a stopgap situation until I get some stuff that my mum left me, and then I'll get on in September and get the next batch of laminations to cut, which is what I've been wanting to do for some time. And trying to cut this stuff manually is a flipping nightmare. Anyway, so I came up with an idea of, rather than replacing the entire lamination set, which we don't need to do, which is something like that. Maybe I should need to get out my paint program as well. Instead of having to have the entire length of everything, the dimensions, the whole thing, like cut every time and change, which would cost more money, I'm going to make I'm going to get these cut initially, and now I'm going to basically hollow out, just to give you a rough idea. I'm going to be hollowing out the sections there so that it's just a frame, and then it's easy to trim out these sections down here if I don't need them. But for now I'll leave that in because we have to have some kind of a basis. But then I'm going to be getting these particular variations cut, which will save a lot of money, and I can slide them in between the other laminations to test out various angles for the flux paths. And just zoom in a minute. I don't think I've got that centered. Right, okay. So basically the actuation of the rotors will be pulling on or pushing on the magnetic field that's over here, which could be south. And so we have our laminations sections. We have straight lines running up directly adjacent to the magnetic field for that particular magnet, so that we can actually divert that flux towards the rotors, so that the flux for the magnets that's over here, that could be north, is free to actually travel in this direction along to our coil. I can't draw with this thing, it's absolutely useless, so yeah, it's difficult to draw with the mouse. Anyway, so our coil, that is so messy, that is terrible, that really is bad. I can't do it. Anyway, there's a coil over there, right? So I'm just going to put a C and an R there. That's our rotor actuating point, and our coil will be over there. So our flux will be able to freely travel, because I already tested this with a static version. And when the north is actually energizing our coil, our south pole will actually be cancelled out or drawn off in a different direction towards the rotor magnets, which is north. But when the rotor magnets are actually, let's just get rid of that. When our rotor magnets are actually south, and this is also south, and this is north, what happens then is we have a much stronger south pole field over here, so our north will be diverted along this piece of iron and be drawn back along these lines, these pieces of iron lines down there, and the objective is to try and limit the amount of lensing that can actually travel back to the rotors, because hopefully, well, I have seen this happen, most of the lensing effect will be negated by the magnets that are already static and anchored to the frame, so much of the lensing effect won't even get back to the rotors. Anyway, I've already tested this out, but this new design will be a lot better than what I've got at the moment, which is straight through, which is actually a piece of iron that's running straight the way through, and the lens can pretty much get straight back to the rotors, which is what we need to avoid. And obviously magnetic fields are the action equals an opposite reaction, all that stuff. That still holds true, but it's about trying to limit that amount of reaction. What we're trying to basically do is use a proxy. I can't write on this thing. So it's a proxy, really. This is what we're doing here. It's a proxy array of magnetic fields. So we're getting another magnetic field to do some of the work, and with minimum amount getting back to the rotors. Anyway, I've been observing I have had substantial amounts of gain, but the more I proxy it, the more it's proxied through past these fields, the weaker the output seems to be. But that's why I'm working on these angles. So I've got various configurations, and that's a different configuration, slightly different. Oh, slightly different. I think that's a different one. Hang on. Yeah, I've got a slight difference in the pitch down at this length here. And then there's, well, that's the one I just looked at there. Well, there's a sharp notch in the top there, and that's another configuration. And I made a mock-up of that in some bits of iron which I've set in resin just to test it out statically, and I have noticed a definite amount of gain. So by actuating one end with a static rotor magnet that I'm holding in my hand, which simulates the rotor, I have observed that on one side we have a higher output That's supposed to be a H, by the way. On one side, and on if we reverse this and have the if we have the rotor on this side, I've noticed a lower output coming on this side. So we are definitely seeing a differential of gain due to the configuration of how these pieces of iron are laid out, and in a straight line or at an angle. And as I've told people previously, I don't do math. I pretty much envisage it all in my mind, and I try to work it out in my mind about all this, and then I basically put it down into a drawing if I feel it's worth exploring more. And so that's what I'm currently doing, and I want to make various designs which I can interlace between the lamination, which I can interlace between the other laminations, which will be basically generic, so that I can sandwich these sections in between my generic laminations, and easily swap them out and put different ones in, and to optimize and find the best the best design, really. So anyway, it's titled Jamie because that's the guy at the engineering firm, and I'm asking him questions like what's the tolerances of his laser cutter and everything, but I'm pretty sure I know the answer. I'm pretty sure it's going to be 0.5 millimeters at least, and maybe less than that, because some of the laminations I already had cut, the actual laminations that were in the frame were tied onto the frame with a very thin piece of metal, and looking at that was definitely less than 0.5 millimeters. So I'm pretty sure it can handle that. But I still want to verify it. So these slots are going to be pretty small, but I'm not worried, and it's a very small piece. And the reason why I put these little this little white space down here is because I'm trying to angle the flux so that it actually wants to travel along these pieces of iron in a straight line. Now, another thing to note is that the actual pass through for the flux is, if you look carefully, it's line of sight. Basically, with the flux sees a straight line along this piece of iron. Oops, I can't do this straight line of sight to the top there. But going crosswise, there's a lot of gaps, so we've got more air gaps in that direction. So the flux will actually want to be travelling down the iron, more so in along these pieces of iron than it would want to be travelling in horizontal directions. So that's the reason for the gaps. It's not because I'm expecting all of the flux to be travelling along those pieces of iron. It's just that the majority of it will, simply because it's the path of least resistance, as they call it, you know. It's the path of least resistance that we're counting on to actually help to divert and control the magnetic flux along these pieces of iron. And it's a very small piece as well. I mean, this actual section is only 7 millimeters tall, so that's the reason why these little cutouts have got to be very, very small. I'm working with in a very constrained space. So obviously it's experimental. We don't know what the result's going to be, but that's what experimenting is all about. Anyway, just a little video update. I'll probably stick it on YouTube later on. Anyway, thanks for watching. I better cut it out now.